Welcome to Driven. I'm your host, Paul Perrone. We're going to learn and talk about AI, robotics, autonomous vehicles, and so much more. Check us out at driven.show on the web and give us a thumbs up or subscribe here if you like the show. So kick back or buckle up and become driven. Ray Russell, it's so good to see you. It's been like a spell.
It has been longer than it should have been.
It is. It has been. I was thinking about how we first kind of met, and it goes back to the DARPA Grand Challenge days, I believe. And I was on a team, and a gentleman named Jeff Wondry from SICK, the company that made the lidar that was very
Yeah,
popular back in the earliest of the Grand Challenges. It had a single beam that just sort of rotated 180 degrees and gave you one line, one field of one straight line of what you could see out in front of it, in this case of an autonomous vehicle. And he told me about this gimbal that you made that sort of went took the lidar and made it go up and down and up and down. And that was really
right.
like what we use today in terms of 360-degree lidar, but it was this sort of economical, almost commercial method for getting 360-degree type point clouds. And I just thought it was brilliant back then. And I just wanted to see if you have any recollection of that and how you came to sort of working with SICK and the lidar and just on autonomous vehicles in general.
Yeah, I guess that must have been where it started. I was thinking about that recently too. Is I know we had an email exchange, so I don't know if you'd reached out to me in regards to the laser or if we. I do remember you at the Grand Challenge, and I remember the vehicle, and I remember the excitement of sitting in the stands in the morning when the sun came up at 6 a.m. It was like it really was almost like this is the dawn of a new age, right? when we were all very excited about where this was going to go, not knowing what the next 20 years of hard work was going to look like to get there. But yeah,
I
I think
know
that's where it
it
started.
was very early, and
Yeah,
all of the different people who showed up were certainly early to this event, and there were so many different machines in the earliest days. Someone had a motorcycle. There was all
yeah,
kinds of different contraptions, and then I think by the second or third race, pretty much everyone converged on normal cars and normal
yeah,
vehicles because they were like, "We're
right.
done with
Yeah,
these custom machines like we had in the
yeah,
first one."
yeah,
Then in the second race, I think it was the DARPA 2005 Grand Challenge. What was Team Dad created this early Velodyne lidar. I think they were charging teams half price, which was 250,000, if I'm remembering correctly, or maybe it was half of 250,000 to buy this lidar and put it on the vehicle, and but we couldn't afford it. But it was the first sort of 360-degree point cloud type lidar that was at least buyable, purchasable at some sort of commercial level by companies like ourselves and people who participated in the challenge. But you had this concept of this gimbal lidar where you took these two sort of single plane lidars and sort of moved them up and down. Did you sell very many of those back in the day, or?
yeah.
Um,
So that was a joint project with CMU, and we eventually licensed that technology from them. And of things when you look back as an initial entrepreneur, we really missed the window there. I should have got a software guy on staff and just stuck my foot straight to the floor on the gas on that one because we let that one get away. We were in front of everybody for a year and a half, but I just wasn't a good enough entrepreneur at that point to recognize it. Um, too conservative. But we did. We probably ended up selling 100 of those units in every kind of conceivable application. We mounted them sideways and rotated them 360. We mounted them vertically. We mounted them upside down. We put them on a blimp in Japan. They ended up in a lot of places. But, eventually you know, somebody grabbed that technology and turned it into a product. And I wasn't smart enough to be able to do that.
well, well, it's, a lot. There are a lot of lidar companies that have since come and gone too.
Yeah,
So it depends on your perspective. It's funny. It's like, and very often I feel like when we're talking to the young engineers, back in my day,
yeah,
we had to gimbal our lidar to get these three fancy 360-degree perfect point clouds. But it's just amazing what where things went. And I guess that was 2005 to now.
yeah,
um Less than 20 years. Just things went from $250,000 to maybe 2,500, right, at some sort of commercial level, and probably even less to get into the automotive market. These have to be $500 per unit
yeah,
devices, right? So,
yeah,
and we're getting there, and just so much more resolution, so much more distance. And but Sick as a company is still going strong. I mean, they have a strong presence in the industrial, um, manufacturing space,
yeah.
and with all their sensors, not just lidar, but yeah. So those were the earliest of days I remember. So and then, one of the things, you were also heavily into autonomous ground vehicles. Your team, RoPro, just did a number of different vehicles. And then I know we worked together on a drop-in kit on a project that we had going. And but tell me a little bit about how you got started with autonomous ground vehicles and what you were doing at the time.
Yeah, that's I recently was in a conference where I was asked to talk about that, and I thought, boy, when you're 30 years old, it's really easy to have that conversation. When you're like 60, it's like, wow, that's a long road. But the short story is, I'm a aerospace engineer by degree, and fighter jets, that was my passion, and I did that up till I was about 40. But once the Cold War ended, they started stretching out the design processes for those jets. It was like 20 years to get a jet, to get a jet out the door. And looking back now, I'm an unrepentant prototyper. I like to see stuff turn around real quick. So that was really starting to drag on me. And just by dumb luck, not because there was any intention, I ended up at a place that was doing aerospace and robotics simultaneously, and they needed some help in the robotics department. And one thing leads to another, and 25 years later, you're a robotics engineer. Um, but the great thing about it, Paul, was because robotics was so early at that point, you didn't have to have any background in it because there was no background in it, right? So I was lucky enough to like basically grow with the industry. So even though I was totally incompetent in the field, I wasn't any more incompetent than anybody else was. Um, so I did some work with CMU for a while just as a consultant, just because I knew where to drill the holes and I knew how to weld. It was that kind of skill sets they were looking for at that time. And then the contracts got too big, and they finally said, "Hey, we can't work with you as Ray Russell. You need to form a company or something." So I formed RoPro Design, and that's basically how it all got started. Yeah,
But you had a lot of interesting different machines, as I recall, not just automating cars and trucks, but unique vehicle platforms.
everybody was looking for. You just never knew what was going to walk in the door, and um, because we had a kind of particular skill set in building things, yeah, we got a lot of different projects. You probably remember the one. It's probably my favorite project, the most worthless one, the Conan O'Brien couch that would hug you when you sat in it. Do you remember that one? You may have never even seen that one.
I remember you telling me about it, but mention that again. What
Yeah,
was the gist behind that?
it was just completely out of the blue. We got a call from like basically one of these. I'm trying to think. The company was Deep Local, which is a great company. They do like I can't even imagine what I guess like almost like art installations for some new, like if Google has some new thing coming out, they'll do like a weekend in Times Square, and Deep Local puts together that experience. And they said, hey, Conan O'Brien's coming back to New York City. He's been gone for like 5 years, and they want to have like this big party for him. And they opened up this museum of fan art. Apparently, these celebrities get fan art sent to them. They had enough fan art to like populate a 3-story building in New York City, and they wanted some signature piece for the art exhibit. And Deep Local came up with this idea of this couch that you would sit in and it would hug you. The arms would come in and give you a hug, and then Coden laid down a whole bunch of soundtracks. So he was like, "Oh baby, that feels like corduroy," those kind of things. And then they would take a picture of you sitting in the couch, and that was like the experience. They would hand you this Polaroid. It was a great idea, but the couch was just so much fun to build
So
because it was just so different.
you mechanized the hugging of it. It wasn't mobile, but basically
Yeah,
hugging you. Okay.
yeah, yeah.
Interesting. Well, you should have mobilized that.
Yeah,
That could have been
that's
a
what I
whole
told
new.
Conan. I said, we should put wheels on this thing because that's what I do.
And but so one aspect of this new podcast that I've created is not just to have conversations, but also there are informational segments where we talk about the how. And one of the things that you've done a lot of is take vehicles and basically give them drive by wire, quote unquote, capability, right? You add in, you've done a lot of other things, but you add in the motors to control steering on these vehicles, brake and throttle and shift and things like that. So just briefly, like what are some of the technologies that brought to bear, and how does one sort of create an automated steering column, for example, just in a nutshell?
Yeah, it's funny, Paul. So basically, in its smallest form, it's basically recreating a human being, right? If you think about it, and your part of it is the brain and the eyes, right? And my part of it is the hands and the feet. Um, and I've always liked that collaboration between those two. So basically, yeah, you're just replicating, a foot that pushes on a gas pedal and arms that turn a steering wheel, and fingers that can grab a shifter. So and there's combinations of how to do that of motors and gearboxes, of linear actuators and chains and pulleys, and it's just basically hardcore engineering that hasn't changed since the 1800s, but it's just put together in a different way. And the special sauce is what your company brings to the table, which is the perception part of that, which even 25 years later we're still struggling with that one, right? It's a daunting problem because we continue, like on the software side, we continue to do that as a calculation, and as a human being we just do that as a reaction, right? We don't, like when we see a car pull out in front of us, we don't sit there and say, okay, well, that car is 176.7 millimeters from my front bumper, and I need to add 1.6% degree angle to miss it. We just boom, we just make that happen. um, yeah, I find that fascinating part about robotics trying to replace the human beings, because we ultimately, what you find out as a roboticist is we are really good. We're really good at what we do.
Definitely, the perception and all that is a hard part, but I also think getting the control of these actuation points, steering, brake, throttle, right, maybe adding redundancy to get to something that can be commercially deployed in a production fashion. There are there are complexities with that, and I guess what and there are different ways to actuate, say, this the steering wheel, brake and throttle. But would you say, like, just the best way to actuate steering at any point is just to add a rotary motor and just connect it alongside a steering column, or do you go down at the rack and pinion level, interface with other or hydraulic mechanisms or what have you? What would you say is sort of the tried and true method that you think sort of works best for these different ways to control
Yeah,
aspects of a robotic vehicle?
yeah, you hit the nail on the head. It really depends on what the final intent is. A lot of the stuff at CMU, they just needed to have this vehicle move in the next 3 or 4 weeks. So the easiest way to do that is you just put a gear in the steering column, and you add a motor alongside of it. But like what I was doing recently with the Locomation, the trucking company, those trucks came to us already with a steering motor incorporated into the column, because they're doing lane monitoring, right? So it's just a matter of basically hijacking that motor on the trucks, and that's basically been reduced to like a CAN interface, right, rather than any kind of mechanical. So in some ways, I'm kind of like a dinosaur. I'm slowly being phased out because all this technology we've built into the cars is coming from the OEMs directly now. Um,
But they're
uh,
doing, those people at those companies are doing what, you did
yeah,
essentially, right? I mean,
absolutely. Yep.
you would add the motors, and then there may be a CAN interface to that motor.
Yeah.
Now, these some of these motors are like electric power assist steering motors, for
Yeah.
example.
Yeah.
Are they, and they're meant to only just sort of assist the human being when you're driving. Are
Right.
they appropriate motors for just constantly cranking the steering wheel in an autonomous fashion when
Yeah.
as opposed to just sort of giving the assist to a human steering them? I mean, one consumes more power than the other and has a longer operational cycle, right?
Yeah. It's interesting to see where that's going to go in the industry because you're exactly right. The steering assist is just good for like, highway speeds. And as the speeds go down, the steering effort actually goes up. So for like somebody like Aurora, Waymo, anybody like that that's doing the in town slow stuff, they have to beef up those motors to be able to handle those low speed 90-degree turns. For what we were doing with the trucks, we didn't turn the autonomy on until they were nearly up to full speed. So at that point, the lane changing was perfectly okay. The lane changing motor was perfectly okay for doing that. But the problem with those, and it's the same problem with cars, is if there's a hydraulic assist function like power steering in your car, power steering in the trucks, you have to include that as part of the edge case, right? If you're saying, okay, these cars are completely good for all conditions and all weather, any speeds, then you have to account for the potential that the power steering belt goes flying off and you no longer have power steering. So at that point, until the robot can get the car safely off the road, then you have to be able to account for being able to steer the car with just electric power. So yeah, that edge case you have to account for is that, okay, if I'm the only thing left in the system is this electric motor, then I have to have the torque available to be able to steer the car at any speeds to get it off the road safely. So that's a big issue.
I guess redundancy has to factor into all of this as well when you go commercial and production. I mean, I don't know what companies like Aurora and whatnot are actually doing, but do are you seeing that organizations are adding redundant sort of steering mechanisms such that if one fails, the other sort of in a hot swappable fashion takes over? Because if you don't, once you take the driver out of the loop, it seems like you're going to need something like that.
Yeah, on our trucks, that's exactly what we had. We had two completely separate steering systems, and they were connected together on a private CAN channel. So those two talk to one another all the time, right? And if the primary went bad, just before it went bad, it made a last gas message right to the secondary backup that like, hey, I'm going offline. You're in charge now. Our biggest fear is what we always called it, uh, the coronary the coronary heart attack, right? Where basically you don't even have time to send out the message that I'm about to die, right? It just suddenly quits working. So that's like the scariest one, is that you have to recognize that, because with these big trucks going 70 miles an hour, I think we usually use the time interval of 1.2 seconds you were in the oncoming lane if suddenly the truck was out of control, and man, that's not a lot of time to make decisions on what you need to do, right? So, and you know
That
all about
isn't.
that. Yeah, you know
Yeah.
all about that.
Yeah. I mean, at that speed and with that inertia, that's a tough one for the
Yeah.
big trucks on
So
highways.
I think what you're seeing with the OEMs, I think you'll probably see dual rotor motors or dual core motors with separate controllers inside of them, and they'll just monitor each other, and it'll be the seamless pass off, and then it'll be like it is now. This yellow light will come on the dash that tells you need to go to the dealer and address error code 3061, which is your primary steering system has failed and you're just running on the backup right now.
Right. Right. Will they ever take, you think, with the big truck applications, people out of the driver's seat? Or are they just going to, I mean, do you think, I mean, a lot of it is just still driver monitored operations, right, with these big
Yeah.
tractor trailers.
Well, until the guy comes out of the seat, right? Until that guy comes out of the seat, then there's no savings here, and there's no industry, and there's no robotic trucking, right?
Right.
So I think where I've finally settled on it, Paul, is that I don't know if it can happen in the United States just because between the legal system and the press, I'm not sure. All it's going to take is one incident, right? And the cars is one thing. You could cross the center line, you could hit another car, and somebody's going to be killed. But with these trucks, with like you said, so much inertia, they're going to go so far and do so much carnage. How many of those would the press and the legal system, stomach before the government just steps in and says, "Whoa, you guys just need to back off on this until you get it right." And I don't know what get it right means. I don't know what that means. I just don't know what that means.
I know it's interesting. It's we live in a different era than the Wright brothers lived in, right?
Yeah,
Where there were accidents, and there's just access to a lot more information more rapidly, more widely dispersed, and it's a matter of what people will tolerate.
yeah,
But really, it's in many ways, I mean, it's inevitable that there are failures of some sort. How can you have a failure free system is a damn good question that I'm sure a lot of people would like to know the answer to.
yeah,
But there are methodologies, obviously, to reduce risk, and the redundancy is one of them. There are regulations like FMVSS, Federal Motor Vehicle Safety Standards, and then I guess there are other standards for trucking that I'm not schooled in. I don't know as much about highway based trucking applications, but in terms of the regulations that apply to them. But when you add in these mechanisms to control steering on a truck, for example, do you does it affect these standards, or do you or are there methodologies for coupling it in such a way such that the FMVSS or whatever compliance of the vehicle can still be maintained?
yeah. That gets into a real touchy space. Right now it's there is a federally managed organization that does that, but like us, they are still trying to put together we're in front of them. Absolutely, as technologists, we're in front of them. And you're beginning to see some of us as we move out of these companies or the companies collapse, that some of us end up in those government agencies to help out with, writing those new specifications, because they don't, they, and they'll admit this, they're behind the ball. They don't know what's going to happen. We don't know what's going to happen. So that's still a very cloudy area, and to make it worse, a lot of the thing is state by state now. Like you can go to Texas and test, like any way you want to test, right? You take the truck out on the road, turn it on, put the autonomy on. We don't care. We want you here. We want you. We want you adding jobs to the job market. You go to some place like California, very very strict. Pennsylvania was kind of like in the middle. They wanted us to report how many miles we were doing a month. If there were any incidents. So you hope at some point that's all going to become under a federal umbrella, and there'll be better reporting methods and better guidance. But now, yeah, it's just like, there's an incident and they try to address it. It's kind of like what you said with the Wright brothers. As they found out more and more things about airplanes, they would add that to the mil specs or the FAA requirements. And it's still that way. We still run into edge cases in aerospace, even though we've had airplanes for 100 years now. We still run into edge cases we've never seen before, and there'll be a new rev on the FAA specs, and that will include, something to address the latest edge case that showed up.
Right, right. Well, one of the collaborations that we had in the past was on what we called the drop-in autonomy kit. And the idea here was to not interfere with the FMVSS compliance of the vehicle, not interfere with even the ADAS functions, automatic driver assist, safety assist type functions that were in the vehicle, and to even not even affect the resale value of the vehicle because we didn't want to have bolts and things in place. And so
Yeah.
you and your team uh, really worked diligently on coming up with this general purpose drop-in kit that we applied to anything from a Fiat 500 to a large SUV was sort of the scope of vehicles that it had to work in.
Yeah.
And so there's all kinds of things that you discovered along the way with the way, different steering wheels move and different things that you had to do. But the nice thing about that was it was a drop-in kit. It didn't interfere with the FMVSS compliance of the vehicle because it just steered the steering wheel, I should say, like a human would,
Yeah.
and it applied the brake and the throttle like a human would. There was actuators to do that.
Yeah.
Um, and but So I don't know if you have any reflections on maybe one of the trickiest things that was encountered in that project, or maybe one of your favorite memories from it. But I have fond memories of that system, and it ultimately was sold to, I should mention, a company that put it in a McLaren
Oh,
Spider.
wow. Wow.
So it really was general purpose and worked very
Yeah.
well. But
Yeah. Yeah, that one was a real challenging, and I totally underestimated it because I hadn't looked at enough cars, and I'd always assumed that we could just run some sort of like rubber wheel on the outside edge of the steering wheel, right? That was going to be the way we would handle that. Until I found out there were some of these high end sports cars had D-shaped steering wheels, which that doesn't work if you're running something around the edge. So that Yeah, that was really a tough challenge. But we ended up just putting an auxiliary steering wheel on it, right? And then we accessed that steering wheel. So
yeah.
that got around that problem. The real problem, and it was funny. I was just talking with somebody recently about that, about how sometimes you can load these problems in your brain and you just keep going over and over and over again, and then just one in the middle of the night or something, it just pops into your head. But I remember on that one, we were trying to figure out a way not to bolt into the floor to hold the brake and the brake and the throttle actuators. Right, we needed to mount those in the seat area somehow, uh, and not have to drill holes in the car. And I just remember, we found those child restraint little things under the back seat, and that's absolutely what we tied into. And I remember we were at a dealership, and we were just sitting there looking, and I just happened to run my hand through the crease in the seat back there, and I said, what are these things? And the guy said, oh, all cars now are required to have these child restraint hooks. And I said, are they standardized? And he goes, oh, yeah. He said, the seat manufacturers all make the seats the same way. These are the same distance, the same thickness. And I'm like, oh my God, there's the answer, right? And I remember running
Yeah.
through the dealer parking lot, sticking my hands in the backs of the seats saying, oh my God, this is it. This is it. This is how we're going to do it. We're going to tie into because those points, if there was a back seat, those cars had to have those that were mandated by the government. So the government saved my bacon in that case. Uh, yeah,
Well,
I still laugh about
that's
that
it.
one.
It's interesting because, yeah, as newer rules come out, you can sort of latch onto them, but then yeah, the older vehicles, you're not able to we're not able to deal with. And but still, this drop-in kit dealt with, regardless, not only older vehicles but some of these specialized vehicles, as I mentioned, like the McLaren Spider. So
Yeah,
it was an amazing feat of engineering, and I always remember you and your team fondly for it because
yeah,
you guys just knocked it out of the park.
yeah,
Um, and thought of everything. You thought of everything. And then that kit, by the way, um, eventually the requirement for us, our group, relaxed to not, we were able to bolt into the system, right? Because we were now
mm,
going to be hiding the equipment, right? So this drop-in kit that was sort of visible in the cab, and now we were able to hide it and bolt in. And but a lot of, the same principles of what you needed to do, of course, to apply steering, brake, and throttle, applied still in those situations. But it certainly made it an easier problem once you could sort of bolt
yeah,
in instead of, not have any bolts whatsoever, because you had all these clamps and adjustments such that you could adjust it perfectly for any kind of vehicle.
Yeah.
It was a really good design.
I think what's interesting about that, Paul, is I don't know how much we can talk about that, but you know, the idea wasn't that they wanted the cars to operate autonomously. The idea was they wanted to be able to perform the same test with any car over and over again, and it would repeat exactly the same way. Because every time the driver did it, he does it a little bit differently. Like we want you to accelerate up to 60 miles an hour, put on the brakes, turn to the left, turn to the right, and they wanted to be able to do that with every car multiple times exactly the same way, right? So it really wasn't a research into autonomous cars. It was a testing method, right? Or a testing equipment that would allow them to do repeated tests exactly the same way over and over and over again.
Yeah, the applications were interesting in that regards. From our perspective, we were autonomously driving the vehicle, right? Because we were controlling steering, brake, and
Yeah,
throttle, and we had to drive the vehicle according to some prescribed mission.
yeah,
But we also had to have the ability to allow the ADAS functions to kick in and not interfere with them. So yeah, so it was there were a lot of requirements for it that don't apply to just pure full autonomy when you're embedding it into the vehicle like we do now, right?
yeah.
So but then you've done a lot since then, and I want to talk about this robot security concept, but I don't know if you can talk about some of the things that you've done um, in the trucking space or in the agriculture space that were sort of highlights over the last sort of say 10 years since we really worked on that system, for example.
Yeah, the ag stuff. I got involved in that at CMU as well because uh, the ag space is a great breeding ground for robots just because the problem's a lot easier, right? There's very little people to hit. There's no trees to hit. There's no telephone poles. It's this giant flat 30,000 acre farm that all you do is go back and forth, right? So it's the perfect place to introduce robotics. So I always had an interest in it. And I think in 2000 was 2014, I guess it happened. I came really close to selling the company, like signing the papers, kind of getting close to selling the company. And I'm reading through the paperwork in the morning, and I'm thinking this isn't anything like I've agreed to. The lawyers had changed it the night before or something, and I just backed out of the deal, and I was feeling pretty bad because we'd spent a lot of time and effort to get to that point. And then the phone rang, and it was a friend from Australia that I'd worked with a year or so before, and he said, "Hey Ray, we'd like you to come back down again, and do some more work in the ag space with us." And I said, "What? You like 2 or 3 weeks?" And they're thinking, "No, like 2 or 3 years." And it was just like I was burned out from running a business. You know what it's like, man. That's a tough hoe. And I thought, yeah. So I found the guys on my team, places to land, locked the doors, and I went to Australia for 3 years working on autonomous agricultural robots. We brought that team back to CMU, and we worked there for another 2 years in that same space. And then an opportunity came along in the trucking space.
Before we get to the trucking, just want to ask something about agriculture. It is a great application. It's a wonderful application, but I
Yeah,
also know that agriculture has very tight margins,
yeah,
right? You're producing a commodity product. Is there is it commercially viable to create these automated machines? Will the end customers ultimately be able to buy them, or what are sort of the financial expectations without going into any sensitive details? But is it a tough row to hoe? No pun intended.
yeah. That is a super great question. So I was just recently down in Dallas. I met a VC there that's really high up in Toyota. Good friend. He's very up on robotics and ag. He thinks it's the way to go. But he was saying that because most of this equipment is so crop specific, right? I mean, you can't pick tomatoes the same way you pick cantaloupes. That so it's hard to come up with something within that space that can cover a wide range of crops. And you see this in the equipment manufacturers, right? There's like John Deere is not deep into any of the horticulture stuff like the berries and John Deere does broadacre. They do big tractors pulling big heavy equipment across big fields. But you'll see companies like Oxbow that do very specific things like harvesting grapes or harvesting berries. So it's hard to find a niche within that industry that's big enough for a VC to be interested in it, right? So my friend from Japan says, most ag tech is VC unfundable. That's one of his favorite lines. He said, if you look back traditionally at the exits, they're only like, most of the exits aren't much more than north of 300 million. And he said, for a large VC, he said, we're looking for the $2 billion Aurora exits, those kind of things, right? They're not looking for a $300 million exit. So you don't get a lot of investment. Well, then that puts the onus back on the farmers, to come up with that money. And like you said, they're running on tight margins. They just don't have the R&D budget to put a lot of big money really quick, which is what you need to have a disruption in the market. So you get these long, drawn out R&D projects, and I am in the midst of one at CMU that I just can't get the amount of money I need to make a difference now. Each year we get a few weeks of testing, we get a few things off the task list, and then we got to reset for the next year. And worse, it's very seasonal, so your test window is small. And even if you do a two hemisphere strategy where you pick strawberries in Australia and then you come to California and pick strawberries, you still only get you only pick up a couple more weeks of testing windows. Where if you're doing autonomous trucks, you can test every day wherever you want. So the testing cycles draw that out. So you just end up with long drawn out testing cycles, which kills you on the R&D side. You find you got a small market that the VCs aren't really interested in. And it's been a real struggle there. And my friend from Japan says, they're looking at ways to change they think the VC funding for ag tech needs to have some kind of unique funding strategy. He says, when I figure it out, let them know. So yeah, it's very difficult, Paul, very difficult in the ag space. The farmers, they've done it the way their grandfathers did it, the way their fathers did it. So they're very resistant to change. They're suspicious of it. So it's hard to make the sell there that technology can actually help them. So yeah, but on the plus
Yeah.
side, I love working with them. They're pragmatic. They got to see a business case. They're just not going to throw $3 billion at a problem because it looks cool. So from that respect, I actually do really enjoy working with farmers.
Right. Right. Interesting. Now, similar kind of question for trucking. And again, this is just sort of my sort of view, not being embedded in it. It's these are big trucks. These are big vehicles. There's going to be a um, potentially a long process. I don't know how long to until people are comfortable bringing the driver out of the seat of those vehicles, right?
Yeah,
For operating on public roads, unless there's applications where they can have dedicated lanes or what have you. Um, what are what in your experience, not speaking to any specific company, but across just sort of the industry, or what in your opinion, I should say, is the prospect for autonomous trucking beyond what we talked about earlier? You kind of alluded to the fact that might not happen in the U.S. anytime soon or ever,
yeah,
because of maybe the regulatory hurdles or just litigation hurdles,
yeah, yeah,
or even media hurdles. But yeah, what are your thoughts on the industry prospects for trucking?
yeah. So I think a great segue right there is that I was at a conference recently, and a friend of mine gave a talk, and it was absolutely dead on. He talked about, and you probably know that company. It's the company from Japan that makes the airbag actuators for Hondas. Was it Tabata? I think was the name of the company. Do you remember that? and they were having the trouble
Okay.
where there was shrapnel coming from these,
I
and
don't. I don't.
they killed approximately 12 people, I think, with these airbags going off. There was an airbag collision, and the mechanism didn't come apart correctly. There was shrapnel, and people were killed by this flying shrapnel. And he was saying that this company's existed since the dawn of airbags. They were like the genesis of it, and have saved hundreds of thousands of lives. But
Mhm.
they killed 12 people and went out of business because of it. And he says, how many people are you going to kill with
Wow.
autonomous cars before you get that right? And does the industry, the government, does the legal, does the press have the stomach that, we're going to have to kill 50,000 people before we can start saving, however many we kill a year now, 30,000 people a year in cars. And I don't know in the US how that, I don't see
Yeah.
how that equation plays out. I don't see how that plays out.
I know that's a tough one. Um, and obviously, it's governments or anybody making those kinds of decisions are making them with with the concept that there's going to be potentially some fatalities, right?
Yeah.
And but then for the the families and the people who are obviously affected by those fatalities, it's a different,
Yeah.
much different calculus and
Yeah.
situation, obviously. So that's it's a tough one. And I remember similar thing from the railway industry, which I was involved with a little bit back in the grad school days, and then coming out of graduate school. And I remember hearing numbers sort of floated about with respect to what's the risk level in terms of dollars for the loss of a life related to a railway incident, right? And
Yeah.
so, and at the time I was like, wow, you can't put a dollar figure on that. But then again, and then as you start to think, well, how can anybody be um risk free? I mean, with anything, with airplanes, with cars. I mean, cars right now are killing 40,000 people a year in the US alone,
Yeah.
right? That's two large airplanes worth of fatalities per week,
Yeah.
which is a lot, right?
Yeah.
And so, but obviously, if there were those airplane fatalities per week, people wouldn't you wouldn't be flying.
Right.
But it's something that's tolerated for some reason in the automotive world.
It seems to be that people will accept other people killing people, but they're not going to accept robots doing it.
Yeah,
So,
and also just automation. Automation. And where is that trade off between and can you even make, and who makes that trade off? Who makes those decisions, right? For other people,
yeah,
it's a very complicated socio-economic, political problem, cultural
yeah,
problem.
yeah,
And that's why maybe what you allude to is maybe in the US it's going to be different from other places, right? And other
yeah,
certain applications where there's a higher tolerance for risk, like DoD or maybe agriculture. I don't know, or
yeah,
versus consumer-based vehicles on the public road.
yeah. Maybe the sweet spot will be there'll be dedicated lanes open for the robotic trucks. I could see that happening where basically all these interstates have what 100 feet of grass in between them, right, from the oncoming lanes. So maybe eventually that's a huge infrastructure ask, right? So um, I do think I think one of the mistakes we've made, Paul, or one of the things we've neglected, and you see this all the time, is especially with your experience from long years at this, is anytime you try to drop a robot into a human developed system, it's almost always a fail because human beings and robots are different. And I think that's what we're trying to do here. Okay, we got this road system all set up with stop signs, visual lights for, and we're going to expect a robot to be able to act, just the way we do. I think those robots need some help. One of the things I've been talking about recently is I think the next startup I'm going to do is I'm going to figure out a way to put magnets into concrete at 60 miles an hour, because I think a magnetic trail down the middle of those roads at least gives the truck every, every 3 meters, every 2 meters, I'm on, I'm in the middle lane, 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 right? Rather than suddenly, the lidar, the lidar is starting to go bad, or the camera loses a few pixels and you start getting this slow drift to the side, right? I think there needs to be some kind of like breadcrumb for the poor robot, so he always has at least a very simple way to know that he's still, on track.
Yeah.
Uh,
And there's this trade-off though. You make a really interesting point with respect to, can we build robotics and automation to do what humans can do? And of course, there's this trade-off with autonomous vehicles in particular. Human beings we are not biologically designed to to go faster than we can run, right?
yeah,
We can't physically propel ourselves without some external mechanism faster than, I don't know, the fastest runner, right?
yeah,
10 miles an hour. So we're certainly not designed to travel 55 miles per hour. Our eyes and our brains and our, can we really handle that? So put, we've sort of put ourselves in these vehicles that propel us at these speeds, and it's totally taxing our biological limits and capabilities. And, but there are things that sensors can do that we can't do. We have there are night vision sensors, right? We can't see what night vision sensors can see, right? So right there, we can place sensors all around the periphery of the vehicle and see things that our head just stuck in the driver's seat in this one position, like, swiveling left and right. um we it can These sensors can see things that we can't see way before we see them, and maybe at distances and in conditions that we can't see them. But on the flip side, yes, there's the making the software, the brain to be, if not as, certainly as good, but better than what we're able to deal with. So we're still in this mode of, definitely co-piloting, right?
yeah,
Where for a lot of autonomy applications. There are certain autonomy applications where you can go fully autonomous now, 100%,
yeah,
right? Certain
yeah,
autonomy applications, it may be restricted by speed, by, like you say, agriculture applications, fixed domains of operations, where you can go fully autonomous. But in the classic, what everybody thinks of autonomy application, driving on the public roads at 55, 65, 75 miles an hour, with all these edge cases and situations that one can encounter anywhere. Yeah, the human is still going to win out in many cases over autonomy.
yeah,
And we don't know where that tipping point's going to really occur, because it hasn't happened yet,
yeah,
right? You and
yeah,
I can't go out and buy a fully autonomous vehicle right now and just tell it where to go and it'll go there. I mean, Tesla maybe the closest, but
yeah,
they're still definitely not there.
yeah,
100%.
yeah. Yeah, I think you would agree. You wouldn't want Tesla turning those systems on today. You already know what the carnage. There would be carnage within 4 hours, right? And
Yeah.
that brings up a good point. Getting back to the trucking a little bit. Like, okay, well, Ray, if you knew this going in, why did you even sign up for this trucking space? Well, Locomation had a little different spin on it. Was that we were going to pair the trucks up. The front truck has a human being driving it, and the back truck was just following it. So that guy up front can make all those really, really hard decisions that right now it's difficult for robots to make. And then the truck in the back, the driver was off duty. He was asleep in the bunk, but the truck was, basically following the front truck. So you could leapfrog those trucks across the country. I really like that idea, and I thought, there's a way you could start generating revenue and then collecting data and using that, to backfeed that into eventually trying to get to a fully autonomous system. But just trying to do that directly from the start, I just thought that was a big stretch. So I like the idea that Locomation had, where, drone followers, whenever you want to call it platooning, it had many names. I thought,
Yeah.
it's still an autonomous vehicle. It's not tethered to the front truck, so if it decides to make a left-hand turn, it's going to make a left-hand turn, right? But at least The scenario I always come up with, like, if there's somebody in front of you and this rectangular object falls off the back of it, and you're bound by cars on both sides, right? You got to make a decision. Okay, is it better to swerve and hit one of these cars, or is it better to run over this thing that's just fallen off this truck in front of me? A human being, if he sees it come off, he goes, "Well, that's just a cardboard box." I can tell by the way it bounced. I can just run that over, right? As opposed to, that's a concrete block, and I cannot hit that, with the truck or the car. Man, that's a tough one for a robot to make that call, right? But a human being, just instinctively, we're gonna, okay, that's a piece of styrofoam. I'm just gonna blast over it, or that's a concrete block. I cannot hit that. So those kind of edge
Yeah.
cases, and that's just one of the small ones, right? There's millions of edge cases like that. I like having that driver in the loop to make those tough calls until we figure out down the road with artificial intelligence and whatever it's going to take to solve that problem, can get that figured out. So it's a nice interim step. I thought Locomation's, you know algorithm there for getting to full autonomy was the way to go, and it's a shame we weren't able to pull it off.
Yeah, no, that I mean, and it makes very good sense. I mean, that leader follower type model,
Yeah,
platooning, and yeah, no, that I mean, business wise, that's certainly certainly seems to make a lot of sense for trucking. One of the things we're where we initially reconnected recently on was this topic of bringing automation and robots, if you will, into applications where there might be a need for security, and I think one of the topics that it related to was um, like school shootings. Right,
yeah,
there have been uh, a number of these over the years, and what can automation, be it we think of it in terms of mobile robotics, maybe there's static automation, is there anything that can be brought to the table to help mitigate and reduce some of these situations, the, the, the tragedy and the risks, and you've done some work in this area and have explored this and given it a lot of thought, and I wanted to sort of talk to you about that and sort of see what your thought process has been. And so, why don't you just sort of just describe what the idea, the basic concept, that you've and maybe your team have thought of before.
yeah. I guess this all started, as most of it did, with the Sandy Hook incident, right? Because that was such an horrific thing, and then, as they've continued along, the thoughts of these people just indiscriminately walking through these buildings shooting little kids, just, you can't I can't even imagine the fear those little kids go through, and then the hell the parents have to live through after something like that happens. And, you just keep hearing this, our hopes and prayers go out to everybody. And, regardless of which side of the political spectrum you are, I mean, everybody has to agree it's at a loggerhead, right? It's a jam, it's a stalemate. And we're technologists, Paul. We're engineers. We don't do stalemate well. We're solution specialists, right? If we see a problem, we so I started wondering, is there a way that we can inject, a technical disruption into this that makes the political discourse moot, right? You guys can talk about that all you want, how you want to, but, we're going to solve the problem. The problem is we're not going to let these people walk around in these buildings and shoot people, right? We're just not going to let that happen. So we started thinking about, what would that look like? Um, and because, I'm a roboticist, I'm gonna look at a robotic solution to it. Uh, so we started thinking about, well, ideally you would like to just fight back, like C-3PO armed with a gun, right? But you couldn't have that system installed in a school or a mall or an office setting, because of the possibility that, the system could be activated incorrectly, and, now you have the sci-fi scenario of the crazy robot going around killing people, right? So it has to be a non-lethal method, um, of confrontation, and all you really need to do is just buy 5 minutes, right? 5 or 7 minutes until the authorities get there. Because if you've watched any of those videos, I mean, they're chilling. Once the initial 2 or 3 shots are, you would think it would just be total chaos, and that isn't what happens at all. People go into hiding, they quit talking, and it's just dead still. Nobody's in the hallways, and these shooters just walk around without any sort of impedance at all. Finding people to shoot. And we started thinking, what would happen if you could confront them, with a robot that was doing all sorts of crazy stuff, whatever that might be, sound, anything to disrupt the senses, anything to buy you 5 minutes, 7 minutes, anything to keep that guy from shooting more people. Could we do something like that? And I think we can. But it's going to take, like everything else, time and money. We try to Kickstarter. I'm a terrible businessman, marketer, promoter, so we didn't get much traction with it. But I still think it's a good idea because it doesn't seem like over. I mean, how long has it been since Sandy Hook? Has it been 10 years? It's been at least 10 years, and we're still
Yeah.
having people walk into schools and shoot kids. So
Right, right. And I think I mean, now this same thing potentially could be applied to other venues and situations aside
yeah,
from schools, I would
yeah,
think, right? I mean, that's maybe certainly a motivating factor, but there's in terms of its making it more commercially viable, if it's something that needs that, right? There's something there. I mean, there's all kinds of situations. There was a shooting up at a what is it, restaurant and a bowling alley up in Maine, and
yeah,
and
yeah.
right, not too long ago, I think. And um I mean, there's just all kinds of venues and situations. But so the question though is, what what would this robot do? Like, what are some of, and maybe it's more than just one thing. What are some of the
Yeah.
things that it would do? And would this be like a wheeled robot? Would it be tracked? Would it have to go upstairs? Would it be located to a floor? I mean, maybe the answer is all the above, but
Yeah.
and then what would it do when it how would it identify this how would it go to the location of the assailant, and what would it do once it got there?
Yeah. So because I'm not the perception guy, I got to leave that problem to you. So, but let's go from the point where, okay, this is the guy, right, or the gal, because I think that one of them was a gal. I think uh, go from that point forward, right? So let's say if you Paul can give me the target, then I think from that point forward, being able to stick with him or her would not be would not be a problem. Once the target was identified, that robot's going to be in your face. So some of the things we messed around with was fire extinguishers, and I was the subject to all these, so I can tell you having a fire extinguisher sprayed in your face will definitely disrupt your intent. So
Yeah.
we played around with that. We played around with really piercing sound, like a fire alarm sound, but really high decibels. Anything just to break, anything that interrupts the five senses, anything that's going to slow you down. Just the robot physically being in front of you, right? You go left, it goes left. You go right, it goes right. Basically not going to let you pass. It's going to run up behind you. If you do get by it, it's going to chase you down the hall, right? So there's some form of to break that. I'm just going to go around here and shoot kids. We tried probably the coolest thing we built. We built a high speed ping pong ball shooter, like 300 ping pong balls a minute. I can also tell you, being shot in the face with ping pong balls that fast also disrupts your intent. Um, one of the
Yeah,
things
yeah.
we can never figure out a way to do it, but I'm sure you've seen the movie Incredibles, where they shoot like these black blobs, and then when they attach to you, they would like expand, and if they shot you enough, you basically were just incapacitated. I thought that would be interesting with, like, you know quick expanding foam, if you could make something like that. Uh, but all of it would be
Right.
non-lethal. So if it did get loose in a situation where there were people there that weren't involved in it, they couldn't be hurt by any of this. So basically, it's just buying 5 to 7 minutes of time. until the authorities can get there.
Yeah. Well, you would also have cameras on these things and location
Yeah,
reporting, such that any
yeah,
authorities would know exactly where, because when they enter these buildings, they don't know,
yeah.
right? They
They don't know
can
what's
just
going on.
hear the sounds. They might not
Yeah.
know where the individual or people um,
And that and that's the
are.
argument
So
I use
yeah,
against, people always say, well, that's why we need armed guards in the school and all the schools. I said, yeah, but that guy's a father and a provider, and he's not going to walk out into, I'm sure there are people that would do it, but he's not going to walk out into a hail of bullets. He's going to hide behind something waiting. I like the idea of this robot basically is being selfless and is expendable, right? And it doesn't matter if he gets Swiss cheesed or not. You're just going to he's just going to be in the way. He's
yeah,
just going to be in the way. That's what he's going to do.
yeah.
He's just going to be in the way. Um,
And it
and if a
doesn't have
camera,
to be one. There could be
no,
multiple, right? I mean,
yeah, we've been thinking recently maybe it's a drone swarm, right? What happens if you release like 50 $20 drones, into the air, and they know where the target's at. That you can go between multiple levels on the building. I kind of like that. They're cheap. They could be stored just in the ceiling on recharge. The ceiling panel drops out, and 50 of these drones. With they could have multiple things on. They could have stinky spray. They could have bright lights. They could have glitter. Just anything. You're just trying to 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 have as much disruption and chaos into the shooter's intent as you possibly can.
yeah, yeah. And I think the I mean, there are levels of non-lethality too, like tasing and things like that. But I'm sure, obviously, once you get into that level too, there's other considerations, I guess.
Yeah,
Um, obviously, accidentally tasing somebody or or
yeah,
what have you. And yeah, it becomes interesting. But then, it's not to say too that these robots wouldn't have some combination of autonomy and teleoperation and remote monitoring and control too.
yeah, yeah,
I mean, once that's there would, I would imagine, you would have somebody or somebody's being able to monitor what's going on,
yeah,
and direct this robotic platform as
yeah.
well.
I assume that most schools probably have. I'm guessing maybe they don't. All the halls 100% monitored in all directions at all times these days. I would think
Yeah,
camera-based systems. So it seems like at that point, all you need is a mouse, a crosshair, and somebody that says this is the guy. Boom. And once that information is transmitted to the robot, I think it can take it from there, right? But like you said, the initial hard problem is okay. Where is the shooter and how do you designate him? And once you designate him, I think the robot system can handle them from there. If there was multiple floors and it was a mobile robot, then that information would be fairly easy to pass off between robots. Okay, he's coming up the stairs. All right, I'm going to be sitting here waiting at the door when he opens it.
right,
Uh, but
right.
I think the drones could be lower cost. I worry about the mobile robot if it's big. It could be pushed over. So there could be an issue there. I like the drones where they would just be, you can imagine, right? You've been attacked by a killer wasp and hornets, man. That is not a fun place to be. That
No,
is
and
not
I
a
and I
fun place
and
to be.
whenever I think of things, when people start to go through scenarios, right, even with sensors on vehicles, or in this case, should we have a ground-based robot or a drone? One mitigation scenario is to have both, but then you have to
Yeah,
make it economical, right? It has to be, I guess, cost effective. But then, of course,
yeah,
you know, a lot of people would pay a lot of money for such a thing, given
yeah,
who's involved, and again, not just for schools, but for different situations, malls and things like that. But if you had a ground based with in combination with smaller, you say $5-10 aerial drones. I mean, this can be this could be a solution. of multiple robotic platforms, not just one,
Yeah. Yeah.
right? Which could be a single point of failure, you know.
Yeah. Yeah. We talked, is all of that too complicated? Do you just have some kind of fixed base solution right at the entrances? But, you know, a window is an entrance, right? I mean, when it comes right down
Yeah.
to it, if you can't get through the front door, you're thinking, okay, you only got to worry about the entrances. But a window is one bullet shot and the window's open and you're in the school. So yeah, it seems like it needs to be something that needs to be able to move around, follow, chase, pursue, harass, whatever you want to call it.
Hmm.
Yeah, I've been thinking like price wise. I think you're right. You can imagine the PTA. What a great PTA, you know, challenge, right? PTA raising money to buy a robot to save your school. Um, but I don't know what a heart, one of those those jump starters for your heart, those you see those ubiquitous now
Hmm.
across, you know, I think they're like $4,000 to $5,000. It would be nice to come up with a system like that. That might be a little cheap for what the technology is going to be required here. But if the camera system is already installed in the school, then it might just be some software needed to be the designator, and then basically you just have to come up with the cost of the physical robot itself.
Yeah. Well, there are low cost, mobile, smaller platforms.
Yeah,
Mobile. It always seemed like once you get to a certain size, and if it has to carry a certain payload, the price just goes up because of the motors and what have you. But
yeah,
but the but you're not talking about a heavy payload here,
yeah,
of what to carry, and
yeah,
and you're really looking at maybe even like some speed, um, and again the prices are always coming down, um, in with drones and this kind of technology. I mean, the cost of the cost of these little aerial drones is just amazing. I guess
yeah,
I was one of the early buyers of a fairly expensive aerial drone, and I even worked in a project that had some pretty expensive aerial drones. But now it's just amazing what you can buy, what you can
yeah,
get for the money
yeah,
spent. So interesting. I mean, it's a very interesting concept, Ray, and I seem to recall there was like a news story about it with you featured a while ago. Maybe it was a local news story, but I thought it was just a fascinating idea, and something that was just definitely worth talking more about and learning more about.
yeah, yeah, definitely.
Well, I guess you're humble because you are probably one of the most, in my opinion, well informed, skilled robotics guys that I know, in terms of what I've seen you and your team produce from a mechanical electrical systems perspective, and so I'm interested to hear from your well informed perspective where you think we're going with robotics and the fusion of this new thing called GPT AI.
Yeah,
Have you given any thought to that, in terms of how that's going to help or hinder the progress of the robotics space, and maybe even autonomous vehicle space?
yeah. I guess like anything else, Paul, right? It's always sold, like I was saying, like the 6 a.m. DARPA challenge morning, the dawn of robotics, but then actually knowing what the next 20 years was going to look like. I think that AI is probably like that now. It holds all this promise, but there's going to be a long slog ahead of us to sort through what's good and what's bad with it. Um, I worry a little bit about the probably one of the things that has changed recently over the last 10 years with robots is I'm not so anxious or eager to throw people out of the system as I used to be. I used to be say, the trucks are all going to drive themselves, the cars are all going to drive themselves, the tractors are going to drive themselves. But like for a great example right now, we've been working on this strawberry project. It's big machine that picks strawberry blossoms because we work for a strawberry nursery and they don't want blossoms on the strawberries because blossoms become strawberries and strawberry growth weakens the root growth. They're growing root stock. They're not growing strawberries. And initially, that was an autonomous robot, and but we settled on a robotic implement. Basically, we're just pulling this implement behind a tractor, and that guy on that tractor adds for $15 an hour. Adds I get a brain, I get a stereo camera, I get a stereo camera. I got a butt, that feels a vibration that doesn't seem right. He knows that smoke is bad. He knows that fire is really bad. Having just that one brain on that implement brings so much to that system. So I'm not, and with my work with Locomation, I'm not so eager or anxious to throw people out of the system anymore. So I see this cooperative robotic stuff. That's kind of what the future I'm looking toward is. And I like that idea. We're not replacing human beings. We're just gonna help them. Like you said, we're not designed to drive cars at 65 miles an hour. Uh, we're meant to walk at 10. So I like the idea of a cooperative,
Yeah.
future rather than people being replaced.
Co-piloting, yeah, for
Yeah,
sure. No, I
yeah,
definitely see that in many applications.
yeah,
And so interesting. And now, just another sort of future think kind of question would be one of the impediments to the proliferation of robotics has been, to some extent, the cost and the size of motors and batteries. Obviously, battery technology is improving, but not quite at the pace that that processor speeds are improving. Right, for what you
yeah,
can get, like the Moore's law doesn't seem to apply as fast to motors
yeah,
and batteries. And
yeah,
so but those are motors and batteries are at the heart of robotics.
yeah,
A lot of the robotics that we deal with. So
yeah.
what do you see anything, any sort of new things coming out, or new forms of um, new motors, or new power sources that are kind of going to make robotics more interesting in the imminent future?
Yeah, it's like I said, most of what we do is technology from the late 1800s that it just, gradually gets more, electric. We still got electric motors. Some of them are still have brushes in them like they did before. Um, yeah, there just seems to be like you said, with there isn't a Moore's law anymore. It's like it's just going to be uh, a gradual increase in the capability and technology. I was just talking with some friends recently. We were thinking, is there any great thing still left out there to discover, or have we reached the point where, we know what all the rare earth minerals are and they've been put together in every different kind of combination there is? Is there anything left to us, other than just continual refinement? And that's a good question. I'm not sure. I haven't seen a lot of stuff in the electric motor market. You still can't beat a cheap wheelchair motor, for reliability and power. Batteries, it seems like the battery chemistries are the ones that work best seem to be the most dangerous. So, in fact, I was just recently, one of my old robots. I was thinking about putting it back online again. I said, oh, I could put some new battery technology in that, but I'm thinking, those lead acid batteries, they never catch on fire. But if I go with the lithium, I got to worry about the charging scheme, right? So
Right.
I'm not sure I'm going to do that.
Well,
So
there's yet to be discovered laws of physics. We hope, right? I
yeah,
mean, these quote unquote alien or UFO encounters that we hear about, right? Is that just some sort of new new way of propelling a machine that some government organization figured out that we
yeah,
just don't know about? We don't. I mean, those
yeah,
are the things we don't know. But there are things that we are aware of, right? There's quantum computing. There's we think maybe fusion, right? And the ability to kind of get energy for nearly free at some
Yeah.
point, and maybe those technologies will kind of lend itself to applications of in robotics that will really sort of give it a boost. But I was just wondering specifically with motors, because I was fascinated to hear that uh, an interview with, I think it was Elon Musk, where he talked about their Optimus robot, their humanoid robot. They couldn't find a motor that would do what they wanted this robot to do for moving certain arms and limbs or what have you on it. And so they built their own motors. And I thought, well, you know, there's so many motors out there that you can buy. And what was so special about this motor that they had to build? But it's funny. I do remember working just um, I don't know, I guess it was 10 years ago on that project that we had mentioned where we had to have a custom motor built to propel this custom built vehicular platform up to speeds of 55 miles an hour at certain acceleration rates that we just couldn't find a motor that could do the trick, so we had to go and
Yeah.
have one specially built for it. And so it's amazing. I'm just wondering that if there's going to be, if you're aware of anything, since you dabble deeply in that arena, any sort of motors or technology or things that might be on the horizon that could provide some salvation for better and cooler robots.
Yeah, I think one of the big things, at least that would help me, or what I'm always looking for, and I think in some ways it's slowed robotics or hasn't allowed it to accelerate the way it has, is that software is a steep hurdle to robotics, and right now it's guarded by software engineers, um, just because I I'm an expert in Fortran, but Fortran is worthless these days, right? I don't know C++, so I can't control my own robots. I find that very, very frustrating because what happens is that the robot control is basically dictated by the software engineers, right? So the mechanical engineers don't get a say in how their robot operates. And I sometimes, because mechanical engineers tend to be very pragmatic, I think in some ways we could be, if we had the ability to control our own robots, I think there's ways we could leapfrog a lot of complexity in software that I see today. So one of the things I'm always looking for, Paul, is you know I want to be able to control the robot. So give me a language that I can speak. And maybe with ChatGDP, that language is going to be English, right? I'm going to tell the robot exactly what I want it to do, right?
Right, right.
Um, because I don't have time to, learn the latest Linux 3.156 kernel and download it onto the GitHub. And
I
uh,
knew as a hardware guy you would find a way to blame the software guys here for
but
the
I think
problems.
I think it would bring a lot more people into the conversation, or
Yeah.
the ability to especially, like, you always hear this complaint from the artists. So the artists are really screwed, right? They're screwed because they can't do the software, and they're also screwed because they can't do the heavy mechanical lifting. So they have this concept that they want to execute, but they don't have the ability to do either one of them. So it would be really nice to see the artists have an opportunity to explore that space more easily than it is now. So not only building blocks for software, but also building blocks from the mechanical side as well.
Oh, I agree. I agree, and that's an area where I've worked extensively, as
Yeah,
you know, and
yeah,
it's always a challenge, right? To also keep up with the latest greatest
yeah,
software technologies, also to include and incorporate into the design. From neural networks to GPT AI, which we are using now, and other tools, different processing platforms. So from our perspective, on from a software perspective, it's very important to stay hardware sort of agnostic, right? Because that's always changing. You have to have something that enables your application to kind of stay the same, no matter if the underlying, hardware is changing or evolving with over time, right? So that
Yeah.
you can continue to build these building blocks that are and build them at a higher and higher level, such that you can get to that place that you're speaking of, where it's easy for the application, or the artists to create applications, really, from
Yeah.
from a higher level language or a higher level methodology. and
Yeah.
uh, and so and so as a software middleware kind of guy, yeah, we're always kind of like looking down here at the hardware and seeing how that's evolving, and making sure that you can create layers that abstract the change to these higher levels of software, such that you
Yeah.
can build these applications that provide rich ways to create new forms of robotics and automation, and ultimately get to what you're talking about, going into a GPT engine and say, make me a maneuver that's going to parallel park this car.
Yeah.
Boom,
Right.
you got it, right?
Yeah.
um, we're
Yeah.
all we're almost there.
Yeah. Yeah, 3D printing has kind of, you can see that in the industry. It's given people like me, right? I can make shapes now that before the machinist, who barred my entry to making what I really want to make. It's like, you can't make that. That's too crazy. But now I can put spheres inside of, cubes, right? Impossible to machine that, right? But you can 3D print that. So, that 3D printing has opened up, new avenues for me as a designer. So, and I think we'll see that eventually. Like you said, well, it sounds like ChatGPT is going to open that up, for people like me, um, and people like you. And in your sense, you don't have to write that, right? You can go to the next thing that needs to be checked off the task list. So
That's right. That's right.
yeah,
Yeah, and it's not just Chat GPT, which is a kind of a brand name. It's GPT AI in general, and there's a organization called Hugging Face that has open source GPT AI engines and things like that people can download and use to to build these kinds of tools too.
yeah,
So, well, this has been great catching up. Very fascinating conversation from in different industries, agriculture, trucking, to what we did with drop-in autonomy kits back in the day, to your ideas on robot security. All super fascinating. And then to think, again, going back to really what started all this, was our conversations. A very simple conversation. We have a lidar that scans in one dig, one line, and we wanted to just sort of get this 3D point cloud, and your novel solution way back then, that was 20 some years ago
yeah,
plus.
yeah,
And then just to see industry create these these lidar mechanisms that do all that and more at such lower price points. So we're hoping to see advances in robotics and automation in the next 10-20 years that are just gonna really blow our minds. And
yeah,
I think it's gonna be amazing 10 years ahead, especially with all that's happening in the AI space and the confluence of these different
yeah,
industries: robotics, AI, and autonomous vehicles. And that's what the Driven Dot Show is all about. And what you're doing and what you've been doing is been a key part of all of this. So I really
yeah,
appreciate you talking about it. So
yeah. Thank you,
thank you,
Paul. Yeah,
Ray. Thank you so much. I appreciate everything that you've been doing, and look forward to staying in touch.
absolutely. Yep. Always enjoyed our interactions, Paul.
Likewise. I hope you enjoyed the show Driven with me, Paul Perrone, your host. Don't forget to check us out at driven.show on the web, and give us a thumbs up or subscribe here if you like the show. Thank you for listening in. See you soon.